All right, questions today on generics. So this is our first of three bonus lessons on sort of advanced topics, but stuff that I think is interesting and potentially useful. Generics in particular, because you see them in the wild quite a bit. So if you read, write, browse Java code, real sort of production level Java code, you're going to find this feature in wide use. And the reason is that it brings together two things about Java that are very attractive. So, one of the things we've seen in the past when we built our list data structure, when we built our map data structure, is that Java's object model and inheritance model allows us to, build these data structures that work with large categories of Java objects. So, for example, I can build a list that can store any type of Java object, and I can do things like set and get on that list, and then I don't have to worry about what's inside of it. So that list can be used to sort of put any type of Java object in order. And that's how the built-in lists work that you use when you're writing Java code, like an array list and a linked list and stuff like that. They operate on any Java object. So the genericness of that is good, but the problem is that, as we pointed out, and I can sort of pull up the classic sort of little canonical example of this, the problem with this, well, it's right here, right? The problem is that we lose, without this additional feature, these type parameters that we're talking about today, we lose type safety. So I have a list, and at some level, the reason why this happens is that, excuse me, swallowed wrong a few minutes ago. When I have a list and I put something inside of it, it's upcast to an object. And so the list then sort of forgets about, first of all, there's a couple problems. I can put anything into the list, regardless of what kind of object it is. And so at a certain point, my list might end up containing lots of different types of things. That might be intentional, right? There's times when I really do need like a list of any type of Java object for some reason. But usually when I'm setting up any type of collection of items, I have a certain type of item in mind that I want to store. So if you think about the work you guys have been doing on the MP, you have collections like lists and maps that are working with summary objects or rating objects. And so when I put something, let's say I had a list of ratings for a course. Right now you're using a map to do that, which is also fine, right? But imagine I had just a list of them. I probably want, I can use a list of objects, and then what I could do is I could be downcasting everywhere when I pull things out of the list. Excuse me. Since what I get out is a capital O object, right? But that's unsafe, right? And you can see the problems with that here, right? So here I've got a list. This is I'm using the Java's built-in lists and array lists, but I'm using them as what's called a bare list here. So you don't see any type parameters. So I'm not telling the compiler any information about what I'm going to put in this list. I'm just saying this is a list. And when I do that, the compiler and the list is going to store objects. And so when I put in a string and when I put in an integer, that type information that Java knew about is sort of lost at that point. And anything that I get out, I have to downcast in order to use it as the type of object it is. And again, you can find all sorts of ways to do this safely using the, tools for working with types that we've already seen, like instance of and stuff like that. But it's just sort of a pain, and it can lead to these runtime errors. And so what Java did, and I can't remember when this came in, I think it was Java 7, is that they added compiler support for type parameters. And allowed classes to use type parameters. Now, one of the first sort of questions that comes up here is sort of like, what's the difference between a parameter and a variable? And that's a fair question. A variable can store multiple values over the course of the program, right? It's variable. The name implies that. A parameter is something that you can change, but it really doesn't change while the program runs, right? And we'll see this when we start actually looking at how to use type parameters in our own code. The type parameter is set by the programmer when they instantiate the instance of an object that accepts type parameters, but it's not something that then changes. So it's not a variable. I'm talking about parameters for some reason. So the type parameters that we provide allow the compiler to check things for us, right? So instead, and again, so here's the difference, right? So this is sort of like working with collections of items sort of pre-Java 7, and then after the introduction of these new support for generics, now the compiler knows because on line 5, you'll see that I've added information, right? That's one of the things, that we do as programmers to try to allow the compiler to help us. So I need to tell it something, right? When I create this list, this list can store anything. The same implementation of list in Java of array list is used on any type of Java object. But by telling the compiler what type of object I'm going to put in the list, I have, added information to the system, and then the compiler can use that information to check certain things about my code. It knows more about what I'm trying to do. It knows that this list called under, a lowercase list is a list of strings. And so now this this add call on line 7, where I'm adding an integer, now the compiler is going to flag this, right? And so again, you'll see here, this is a compiler error, right? The error above it is a runtime error. That is the thing that causes your app to crash in the user's face, or in the face of the VCs that you're demoing to, who might fund your company, or in the face of your boss at the performance review when the feature that you've worked on causes the demo app to crash or whatever. Not good. We don't want runtime errors. Runtime errors are bad. They typically lead to crashes and other sorts of poor behavior. If we can tell the compiler more about what we're trying to do, so if you look, all we've added here is this type parameter. And then there's also this thing called the diamond operator that basically applies the same type parameter to the right side. So I've got my interface on the left side. This is an interface variable list. It's being initialized to an implementation of that interface, an array list. And I'm using the diamond operator on the right. All that does is basically takes that type parameter from the left and applies it over to the right. I could also just duplicate it. Originally, when I think Java introduced generics, I don't think that the diamond operator existed, but at some point people got tired of typing the same things and they thought it was sort of silly, and so now you've got it, right? But really all I've added to this is this extra information right here on line 5. And if you look, these two pieces of code are identical. There's a mistake here in both cases, right? The mistake is that I'm trying to use this list incorrectly, right? My premise here is that this list is supposed to store strings, and then at some point you got confused in your code and you added something into it that wasn't a string. But in the first example, the compiler doesn't know that the list is supposed to be used to store strings, and so it has no way to help you, right? It sees that add on line 7 is like, well, I hope they know what they're doing, right? They've got some strings in here and some integers in here, and now if we go down here, what we'll see is that, there's actually two changes. First of all, the compiler will help us, right? So let's fix this error by turning this into a string. Now we're good, right? And the other thing that's actually simplified here is I no longer have to do this cast. And that's the other thing that's nice about adding type parameters. So what I put into this list is going to be a string. What I get out is a string. Now, the same sort of rules that we've used in the past regarding inheritance still apply here. So I can put anything into this list that has an is-a relationship with string. Now with string, you may remember, it's final, the class. So I can't inherit from string. So I know in this case, the only thing in this list is going to be something that's an actual string. But if I had, an complicated set of inheritance relationships, like let's say this is a list of shapes, it could be circles and squares and rectangles, whatever. They all inherit from shape. What I know is that anything I pull out of this, I can treat like a shape. If I need more information about the type, I need to do my typical stuff where I do downcasting or I do instance of and then some downcasting or whatever. But I can put anything into the list that has an is-a relationship with the type parameter that I provide when I create the list. And so first benefit, compiler checks things for me so I don't make mistakes and put things in the list that don't belong there. Second benefit, it's cleaner when I get things out since I don't have to do the downcast, because the compiler knows that what comes out is a string, and so you can think of it as almost just inserting the downcast for you. So that's nice. So we've seen how to use these. You guys have been using them as part of the MP. You've been setting up maps, and on some level I think this is a pretty natural idea, right? Because when we talk about a map or we talk about a list, that's a very abstract data structure, right? In fact, I think that's what they're, how they refer to in C++. Because the concrete details of what's inside the data structure are not really that important, right? You can implement a map without caring, and the way that they're implemented in Java, without caring what the keys and values are. All I care about, maybe, depending on the implementation, is that they implement hash code or some other thing that I can use to make the map efficient. But I don't care what's in there. So, again, I think this is sort of a natural idea, right? When we think about a map, right, we typically think about, okay, what are the keys and values, right? So, in your MP, you might be mapping from like a summary to a rating, or from a summary to a course to a rating, or whatever, right? So we've used these. You guys have been using them, and you will continue using them in Java, right? People use these as part of modern Java. It's a feature of the language that people tend to use. What we haven't looked at yet is how to actually apply these in our own code. And so that's what the rest of today's lesson starts to focus on, is let's say I wanted to build a generic class that could accept type parameters. What does that start to look like? And so what we do is we kind of walk through some examples where we take, and we could actually, if you guys want, we could go back to our list implementation that we did together, remember that? And we could generify that. We could go back and take our map implementation, and we could generify that. There's lots of opportunities for taking those old containers that we built, to understand kind of how an array list worked or how a linked list worked, and actually add type parameters to them. And you might do those on your own just for fun, right? In this case, what I did is I basically went back and I took the kind of last n example where we had this class that stored the last n values that were added to it. And we walked through kind of, first of all, how to do that, just using objects without type parameters, sort of pre-generics in Java, and then how to introduce a type parameter. And so that's sort of the next set of examples. Talk a little bit about what happens when the type parameter is actually compiled and how the compiler actually kind of removes that information. Talk about naming conventions and then some other places where type parameters get used. And then finally, this little piece of information about bounded type parameters, which is a way of not just telling the compiler, hey, there's kind of a free variable here, right? But also having requirements for the parameter, right? And so the compiler, so if you think about it, the compiler knows all sorts of stuff about all the classes that are available to it as it's compiling your code. And so you can use that information to be even more specific about the certain type of, about rules for the types that your class can support. So if you create a generic class, you don't have to say, hey, I can support any type of object if you actually can't. So if your generic class needs certain features of the type parameters that are provided by the programmer when they create it, you can tell Java what features you need, and the Java compiler will then enforce that for you, which is pretty neat. So we talked a little bit about that. So that's today's lesson. I'm happy to take questions on this. I think I suspect people that are here because they're kind of curious about some of this stuff. So fire away. And I'm certainly not. I wouldn't call myself an expert on Java's generic system. There's certainly stuff in here that I'm not super familiar with, particularly when writing more complex type bounds and things like this. And so we could look at some of the documentation together if you want. But again, I mean, this is a useful feature. There's also some other bits and pieces of the system that we haven't talked about. So static methods can accept type parameters, which is kind of neat. Things like that. So fire away. I'm here till the top of the hour and happy to take questions about this topic, which again I think is pretty cool, right? We also look at some documentation together if you want to see type parameters kind of in the wild and stuff like that. This is one of those features of Java. When you think about kind of how to teach a language and the type of things I want you guys to sort of know about Java before you move on. this feature of Java is, I think, requires a little bit more kind of higher conceptual thinking. But it's one of those things that's just really omnipresent when you actually try to use the language for real. So when you've probably seen this already. You browse the Java doc and you've seen these, things within triangle brackets, and so it's kind of in your face, right? It's not something about the language that's easy to ignore for very long. It comes up quickly once you start to use things for real, and so that's one of the reasons why, even though we've been focused on the basics this semester, is we're kind of right near headed out the door. I do want you to see this and at least have a little bit of this content to maybe come back to in the future if you get stuck or not feel worried or nervous when you start reading JavaDoc and you see these things around. And because there's nothing super complicated about this, but it's just an additional piece of syntax that we should be familiar with. So, all right, fire away. Or we could talk about other stuff. I mean, I'm very flexible today. We're down to the last kind of couple lessons. So, if you guys have questions about other things, I am at your disposal. Or if people don't have any questions, we can just call it a day. It's fine with me too. It's a beautiful December day here. Welcome to December, by the way. You guys made it very near the end of the semester, but yeah, if you're not in Champaign, it's a bright but chilly. I guess not fall anymore. No, I guess this is still fall. This is the cold end of fall. We haven't seen any real snow yet. So, but yeah, no, it's nice out there. We look forward to getting the dog out later. If there are no questions, I think I will step aside for today. I think maybe for the next couple of days, what we'll do is rather than doing this walkthrough, I'll just set up some sort of office hours session in the afternoon. So I think people will probably enjoy that more. So with that said, I will see you all tomorrow. I hope everybody it's doing okay. Wrapping up on the MP, yeah, I will. I'll maybe see somebody on the help site or on some office hours over the next few days.